problem, we need to use the concavity test to find out the intervals in which the graph is concave up and where it is concave down. Let's take a little bit of a look at what does it mean, concavity. So concave up means the slope, that is y prime, is increasing on that interval. So if I have a function that looks kind of like this, well, clearly the slope, the slope is kind of flat here, and then it's getting bigger there and bigger there. So here the slope is increasing on that interval. And same logic, if it looks like this, then here it's kind of flat, but now the slope is decreasing. So really, what it is, concavity is just like the first derivative determines whether a function is increasing or decreasing. Concavity determines, the second derivative determines how fast the function is increasing or decreasing. Because remember, the derivative is the same thing as the slope, which is the same thing as the rate of change. So if my second derivative is positive, that means the rate of change of my slope is getting bigger, and it's concave up. If the second derivative is negative, the rate of change of my slope is getting lower, it is concave down. It might be really helpful to have a picture of this function as we go about solving this problem. So here's a picture of the function. We'll come back to it. But I'm going to start by finding the first derivative of this function. So y prime is equal to, well, that would be 2/5 x to the negative 4/5, and the 3, that goes away. And then y double prime, the second derivative, well, that would be equal to negative 8/25 x to the negative 9/5. Let's just simplify that so we can see what that looks like a little bit better. That is equal to, and I'm going to do this in 2 steps, even though I don't have to, I'm going to. It's equal to negative 8/25 times 1 over x to the 9/5, which is the same thing as saying negative 8 divided by 25x to the 9/5. That little step might help some of you in the algebra on some of these problems. So going back to my, my definition of concavity and the concavity test, I can see my concern is where y prime is going to be greater than 0 or where y prime is going to be less than 0. And the only place that I can change from greater than 0 and less than 0 is where it equals 0. So I'm going to go to my second derivative here, and I'm first going to see if I can find out where does it equal 0. And I'm looking at it, and I don't know. There is no way that I can make this equal to 0. Negative 8 is negative 8. So y double prime is not as well as is y double prime, come on, equals 0, no place. Well, where else might I have a change in concavity and y double prime? I might have it where y double prime does not exist. And I do have spots where I do have a spot where y double prime does not exist, and that is where x equals 0. So where x equals 0, y double prime does not exist. And that's the point that I'm going to look at. So I'm going to take a look at my, I'm going to make a number line. Make a number line here. And here is 0, and that's going to kind of divide that into 2 intervals. And I want to find out whether y double prime is greater than 0 or less than 0. Well, let's test a number. Let's test -1. Well, if I plug -1 into this, well, the only place I can plug it in is right here. And if I have a negative number, and I take it to an odd power, 9, it's still going to remain negative. And if I take an odd root, it's still going to remain negative. So this is going to be a negative number. My top is a negative number. So my derivative is going to be positive. So in this interval here, it's going to be positive. And if I try the number 1, well, I think you can see. This is going to be 1. 1 to the 9th is going to be 1. The 1 to the 5th root is going to be 1. So I'm going to have a positive number on the bottom, a negative number on the top. This is going to be negative. So my graph should be concave up over the interval -infinity to 0, and it should be concave down over the interval 0 to infinity. Let's go take a look at our graph. Well, I would say that my slope of the graph, kind of low there, but beginning to increasing a lot, and it really increases over here. And when it gets to x equals 0, well, that's actually vertical right there because it does not exist. The derivative does not exist right there. So, but then my slope is very steep, and it starts to get more and more negative. So I would say that this is the correct answer to this problem.